we're going to take a database that's in second normal form and we're going to convert it into a database that's in third normal form. To say that a database is in third normal form, it needs to meet the following criteria. It needs to already be in first normal form, it needs to already be in second normal form, and it needs to be such that there are no dependencies on non-key attributes. And that's what we're going to look at here. We're going to look at and explore what we mean by that statement. So what we mean by no dependencies on non-key attributes by looking at an example. This is the database that we are going to convert into third normal form. It's already in second normal form, and there are videos explaining how that's been achieved, so you can refer to those if you wish to know more about that. It contains 3 tables. The bottom 2 tables we don't need to worry about, but the top table there are dependencies on non-key attributes. What we want to do is to create a nice grid of the non-key attributes that we have in that top table there that contains our dependencies. So you can see our non-key attributes are course, teacher name and teacher phone. So we have those going along the top and also down the side. And what we're going to do now is go through each of those non-key attributes and determine whether they are dependent on either of the other 2 non-key attributes. We're going to begin by looking at the dependency between the non-key attribute course and the non-key attribute teacher name. Because there's only one teacher teaching a particular course, that course will always be associated with that teacher name. So for a given course, the teacher name will always be the same person. Now, course, because it's a non-key attribute and teacher name is dependent on course, then we can say that the database is not in third normal form. Conversely, because the same teacher can teach more than one course, we can say that the course is not dependent on the teacher name. Now, without going into too much detail, using the same thinking, teacher phone is dependent on course in the same way that teacher name is dependent on course. And for the same reason as teacher name, course is not dependent on teacher phone. Now, for the final dependency, looking at teacher phone and teacher name, we see that it's dependent in both directions. So in this context, what we're saying is that a teacher only has one phone and a phone is only associated with one teacher. So in this case, we have a two-way dependency here. Given our completed grid, we're going to apply this to our table to break this up into 3 other tables. So let's have a look at how we do that. Now, the first table here, we've got teacher name and teacher phone. Because there's a two-way dependency here, we can put that into a separate table. So we've taken that out of our original top table here and taken out teacher name and teacher phone. Next, we have left in teacher phone with our course code. Teacher phone, we can think of it as our unique identifier. We could use teacher name, but we'll go with teacher phone here. That's more likely to be unique than a teacher name. And then the final table relates to the course code and the course. So teacher name and teacher phone we're taking out because there is a two-way dependency there between those non-key attributes. Teacher phone then can remain in course code as the primary key, linking our teacher table to the course table, and then we've got the course code and the course, which again intuitively go together, and we've effectively left those in our table. The final database in third normal form now looks like this. It consists of 5 tables, including those 2 tables that we removed earlier in the process because we didn't need to do anything to them. Looks like this. So it looks pretty complex with many-to-many relationships there, and you can see how those are integrated together